Okay, so for the last 2 days, we have been multiplying rational expressions. Today, we're going to start with dividing, which is exactly like multiplying, except we have to keep change flip. We have to multiply by the reciprocal. So, process for dividing, a refresher here. Simplify each fraction if you can. So, in our refresh example, 3 over 4 cannot reduce, 1 over 8 cannot reduce. So, those are fine. Second, keep change flip. Multiply by the reciprocal. We have to do this because we cannot, when we divide, it's the same as multiplying by the reciprocal. And then we simplify our remaining expression just like we've been doing when we multiply. So in this refresher example, 3 over 4 stays. We change it from division to multiplication, and then we flip the second one. So we keep the 3/4, we change the multiplication or the division to multiplication, and then we flip the second one, always. Okay, then we multiply straight across just like we've been doing. 3 times 8 is 24. 4 times 1 is 4. And then 24 over 4 is 6. And that's it. All right, so process for dividing rational expressions. Factor everything first. Simplify if you can ahead of time to make life easier for you. Multiply by the reciprocal. This is probably going to be the biggest thing that you forget to do. Monomials, same rules apply. You multiply the coefficients, add your powers when you're combining. Binomials and trinomials, just leave it in factored form. And then, as always, make sure you have fully simplified everything and include your restrictions. As a reminder, find your restrictions after you have keep change flipped. And then make sure you do it before the simplifying process so you don't lose any restrictions in that. And it's easiest to do after you have factored everything. Okay, let's look at the first example. We like to go ahead and leave simplifying to the end because even though it's bigger numbers, it's less work for us to have to do. So the first thing we always want to do with division is keep change flip. So keep the first one, 5PQ over 16P3, multiplication, 8Q5 over 35P squared Q squared. Now you can go ahead and multiply all the way through, but I also recognize that 16 and 35 are going to be a pretty big number, but I can simplify them already with these coefficients. So 5 goes into itself once, 35 7 times, 8 goes into itself once, and 16 twice. You can go ahead and multiply. Well, let's go ahead and do that. So up top, that leaves me with PQ over, no, that's not what I wanted to do. Sorry, thanks for bearing with me, guys. I want to go ahead and multiply everything through. So this P1, Q1, and this Q5 up in our numerator right here is going to simplify to, there's only one P still there. And then Q1 plus Q5 gives me Q6. Now I'm going to go ahead and multiply those coefficients in the denominator. 2 times 7 is 14. And then P3 can combine with the P2 and give me P5. And then Q2. So simplifying ahead of time in this case was a little bit more helpful. Now we can clearly see a little bit more. Let me pick a different color. The 14 coefficient has nothing to simplify with. My p's, however, that can go away, and we can be left with 4 on the bottom. Q6 and Q2. The Q2 can go away. 6 minus 2 is 4. So our final solution would be Q4 over 14 P4, where we can't forget our restrictions. If we look in the original denominators, both of these are monomials. And we said before, with monomials, P and Q cannot equal 0, because if either one of those variables is 0, then it would make the whole denominator 0. So that is it for example 1. That is your final solution. I'm going to go ahead. I know this is a long video. Thanks for sticking in there. I'm going to try to break these up into 2 videos to make it a little bit easier for you guys, and to make sure that I don't make quite as many pauses or long extensions like I did in the last one. So step 1, we want to go ahead and keep them flipped first. So 10 over 4x minus 8. It's a weird looking 8. X squared plus x minus 6 over 2x squared plus 6x. Now the next thing that we want to do is label everything so that we can factor it. A is prime. It will just say 10. B, I can factor with a GCF, which would be 4, and that would be x minus 2. C, we would need to do x method. X, 2 numbers that multiply to give me negative 6, that add to give me 1. So that would be plus 3, and x minus 2. And B, GCF as well, which would be 2x, x plus 3. And as you can see, just from factoring, we have some things that we'll be able to simplify out. Come on. Okay, so putting it all back together, 10 over 4, x minus 2, that's an x. C was x plus 3, x minus 2, oops, 2x, x plus 3. All right, so now would be a good time to talk about restrictions. So restrictions, our denominator cannot equal 0, and since we already have everything factored, it's a lot easier to see. So in our first denominator, x cannot be 4, which is a true statement. 4 is just a scale factor. Or x minus 2 cannot equal 0. You would add 2 to both sides, so x cannot be positive 2. And then in this denominator, 2x cannot equal 0. Divide by 2, x cannot equal 0. And then in the other factor, x plus 3 cannot equal 0. Subtract 3 from both sides, and x cannot be negative 3 either. So back in our restrictions, x cannot equal 2, 0, or negative 3. We've got those covered, and now we can start to simplify some things out. So x minus 2 can simplify out, x plus 3, 1 in the numerator and 1 in the denominator. And then you can do the 4 and the 10, or the 10 and the 2. Doesn't matter which one. I'm going to pick 10 and 2 because to me. That's just easier. So I'm going to have 1, 2 goes into itself once and 10 times, and 10 comma 5 times. So our final solution, and I'll try to write it in a blue so that you can see it better. All I have left in my numerator is 5 over 4x, where x cannot be all of those restrictions, 2, 0, and -3. And hopefully you can organize that a little bit nicer on your sheet. If you have any questions about the notes for this one, example 1 or example 2, please let me know. Or if I need to clarify anything or the handwriting, I know it's a little bit messy. I appreciate you following along and diligently taking your notes.